Let us in this presentation discuss about Elasticsearch compound query. So compound queries are just the wrapper to the leaf queries. So compound queries are mainly used to combine a number of leaf queries together. There are a number of compound queries are there. That is Boolean query. This is mainly used when we want a number of leaf queries to combine them together by using any Boolean operator. Next one is the disjunction max query. Here we will write a number of leaf queries there under this, and out of those the particular leaf query which will produce maximum score will be used. Next one is the function score query. This particular type of query is useful when you want to manipulate the score, that is the relevant score, by using any particular field, that is by using any custom field or by using any custom formula. Then this particular query is useful. Next one is the boosting query. Here you will write a number of queries there, and under which you can use them to boost to the relevancy score. Might be it is a positive boosting or a negative boosting. If anything matched with the under positive boosting, then it will contribute to the relevancy score, it will increase the relevant score, and if matched with the negative boosting, then it will be reduced, that is the relevancy score will be reduced. And next one is the constant score query. Here when you want a particular type of query to provide some constant relevancy score, then it is useful. Now let us see one by one all of them. So Boolean query is useful when you want to combine a number of leaf queries by using any Boolean operator like AND operator, OR operator, and NOT operator. So for implementing AND operator, we need to use bool.must. This bool.must is nothing but a JavaScript, that is JSON array, inside which we need to write all the leaf queries. Similarly, for OR, we need to write bool.should. This should is also a JSON array inside which we need to write all the leaf queries which we want to combine by using OR operator. And similarly, for NOT operator, we need to write bool.must not. This is also a JSON array. And there is another thing that is called bool.filter, and this is also used to combine a number of bool.filter, and this is also used to combine a number of leaf queries by using AND operator. But there is a little bit difference between bool.must and bool.filter. When we write anything inside bool.must, that query will contribute to the relevant score. But if it is written inside bool.filter, it will not have any impact to the relevant score. It is useful only when you want to filter out the documents by any particular matching. Now let us see some practical example in Kibana console. So let us write the bool query here. So first it will be just post index name underscore search. Okay, then inside curly bracket we'll be writing the query here. Okay, so first is the query, this is mandatory thing, and inside which we will write everything. And let's write the bool query. For this we need to write bool. Inside bool, if we want to use AND operator, that is all the leaf queries will be combined by using AND operator, then we need to use must. So let us write must, and we already mentioned that must is a JSON array, so we are saying it has been automatically created. Okay, and inside the array there is the first element here. So inside this we will write our first leaf query, that is particular leaf query we are wanting to execute. So say we want to match a particular term, so we will write match query here. So match, say book name, and we want to match a particular term, say it is time. So this is all. This is a single leaf query we have written. Okay, if we run this, we will get result, that will match with this particular term. Now if we want to satisfy more conditions, that is it should be matched with this term, as well as the author name should also be matched if we want, then we need to introduce another leaf query here. So this is our first leaf element, and there will be another leaf element here. Now let us write our another query. Let me just collapse it. It will be very easier to get the visibility. Okay, so here are our two elements. We already have written the query inside this. Now I am going to write inside this. Say it is also, sorry, it will be here. So it is a match query. So match, and the field name is, say, author name. Author name should contain Stephen. Okay, so our query is the book name should contain term time, and the author name should contain Stephen. These two conditions must be satisfied to get the output. Now let us run this. So this particular document satisfies both of these conditions. That is why we are getting the result. But if we just change it, say I write it column, then we are not going to get any result, because there is no documents there which satisfies both of these conditions. But if we change the book name term, say it is fire, then we are going to get result here, because this particular document is going to satisfy both of these conditions. So this is all about the must. If we want to add more conditions there as per your requirement, you can write it. Say another condition, you want to match a certain value, that is the number of copies. Say here we need to write the range query for this. Say this is number of copies, and there is a range 10 to 20. So this contains value 1000. So here this condition satisfied for this document, this will satisfy, this also will satisfy, but here it will fail. So as per the truth table of AND, if any condition is false, then it will be entirely false. So here in this case this condition fails, so we are not going to get result. Let us run it. Okay, it's not producing any result because this condition does not satisfy. Now let us change its value 1000. Now all of these conditions will be satisfied, so we are going to get the result here. Okay, so this is the must query. Now let us move to the OR query. So for that, let us just copy this here. Okay, now query bool. So for OR we need to use should. Here it is. Okay, exactly same like must, but the working will be different. So we write our first query here. Say we want to match book name is with time. So if we run this query, we will get result, because this particular document has book name as time. And now we are adding another conditions, that match author name as column, say. Okay, so here we are going to get many results. We are going to get this one, along with this we are going to get all of these results also, because this condition satisfies for these documents and these conditions satisfies for this particular document. And as it is OR operator, so satisfying any one condition out of those will produce result. Okay, so this is the example of OR query, and that is bool.should. Now let us see about the must not condition. The must not is also exactly same. Inside bool we are going to write must not. So must not will be used when we are expecting to run not query. Say match field book name time. So the document which contains book name and the term time exists in the book name, that particular document should not appear in result. Let us run it. Say we are going to get this wings of fire, this ignited minds, but we are not getting the brief history of time book because that we have written inside must not condition. Okay, now let us see the example of the filter. Okay, so for seeing the filter operation, let us go to the first option we did, that is the must. Okay, must and filter both are same, only difference is that the relevancy score, the contribution to the relevancy score. If we write anything inside must, then it will contribute to the relevancy score of that document, but if we write anything inside filter, then it will not contribute to the relevancy score. Okay, so if we just change this as filter, then we are going to see that it will get some constant value. Okay, the score is 0.0. okay, it is not producing any score there, but the result is same, just the relevancy score is different. Okay, let us make it must again. Now we are going to get score as something which it has calculated based on all the filter condition. Okay, now if we just move any particular condition into filter, let us keep this 2 in must and move this author name thing to the filter. We can combine this, just we have written here must, inside along with must we can use the filter also. Okay, so inside filter we have written this. So let us see what happens here. The working will remain same, that is the result will remain same here, but it will have some impact into the score because till now this particular match was contributing something to this score, but now it has been moved to the filter, so the contribution of this query will not be present here. Now let us run this. So we are seeing that earlier it was 2.4 something, but it has been reduced. Okay, because we have moved this particular query to the filter. Okay, this is how the filter works.